Hello everybody. Today is an important day because we will be talking about one of the most important functionalities in programming, like all of the programming sphere. And it's about classes and objects. Let's say in Python we have this possibility of having these OOPs, like oriented object programming paradigms, and with today's class we will be talking about it. So if you haven't subscribed yet, please subscribe and just say I subscribed in the comment section. It would be really nice and you will help me get to at least 20,000 subscribers, and that would be really nice since now I'm around 1000, and it would help me really upload more quality content for you. So forward going, we'll be also talking about scopes and namespaces. So here we have some really important, let's say, instructions in Python that are called, for example, non-local or global. In here you can see we can say that this spam is non-local variable and this global is a global variable, and we can put them in a function. And let's see what will happen if we run this function. Here let's say, okay, we have a spam variable. So if we do local variable, because here you can see that in this function we can actually have different functions inside of a function, and we can also actually use the scopes of this function. So here if you see we are just running a scope test, and we are trying to run this scope test, and we'll see print in global scope what is the global one in the scope, like which spam is the global variable. If you see here, spam is not defined. It's not defined outside of this function. So let's see what will happen if we do a scope test. Here we define spam inside of this test of this scope, and we name it first of all like test spam. And if we do local, we will run this function. So we will say, okay, no local, do local. We will have this one. So do local, we will have a local spam. Next, we'll have the do non-local. So we'll have so for do local, the first print is do local. So after local assignment, we have test spam. So it's the local assignments here in the scope test, and we do this local. After we will try to with the scope test we will print, okay, after local assignments we'll do local. Here we don't print anything, and we will print after the local assignments what we have. We'll do the non-local, and we see after the non-local assignments what we have. So here after non-local assignments we have the non-local spam. So here we access this spam actually. This, if you see normally, if we don't do this non-local spam, this spam wouldn't really change, and now we are kind of changing it with this non-local function. And here we will do the do global, which is also very important. We will have a global variable spam, and we will have after global assignments it's spam, it's this global spam, and we will have do global and print after global assignments. So after global assignments, if you see, we still have our non-local spam. We still have the value that got in the non-local. So here we could do the local. We'll just have local and it will be normal. Here we have the non-local, so we go and use it on this spam, and here we define spam as global. It's not a local variable anymore, but it's a global. And here it's like we define a spam variable outside this whole scope. and it will be with this variable that is in the outside scope. We will name it global span. So here, after global assignment, we have nothing. We have the previous variable of the non-local span. It's the most important thing to note is here, if we print this in global scope, what is span, which is not defined actually outside of this scope test, we can access it and we won't have this name error. Now we have the global span in here. Next, so this is basic tests of scope of the scope in Python, and something that is really important to grasp in programming languages. Next would be about class definition. This is how we will define a class in Python. So we have like a class name, and this is the normal syntax how to really write class names. We won't use snake case anymore. We'll use more a camel case with the upper in the first let's say character of the class name. And we have statements, and statements they can be any statements in the class. Here we have a simple class. We'll create some class objects. So we have a class, my class, a simple class example, like it's a docstring, and we have an I variable in it, and we have a function in it, which we called a method. A function inside of a class is called a method. So it's a function that has something to do with this self. Self is like the objects of the class. So a class is used to generate objects. So we will use this kind of class objects in this in Python. Something that might be different from other programming language. This self here. So here f of self. And also this self makes you define methods. Actually, if you have some function without this self, it's not a class method. It's like just a utility method, I would say. So here, if you say my class, we can say x. Okay, I have to run this one. You can say it's x. It's my class. We call this. It's like instance of class or object. Let's say x is an object of my class. These are what we like some OOP paradigm or object-oriented paradigms. Let's say here OOP paradigms, or yeah, say object-oriented programming. This is some object-oriented programming. Next, so we have seen that we can instance the my class class and affect it to x. So x is a class attribute. It's an object of my class. So we can access those variables inside of class with this kind of writing. Can do x.I. We can access it, and we can call the x.f, and we will have the hello world. So this is something really important about classes. We can define, let's say, attributes, and we can define methods. So this is called an attribute of the class. You will see that Python deals with attributes of classes. Python deals with oriented objects programming in a very nice way as well. Here we can create some class that is complex, from math complex, and it's like a number. We want to represent a number, a complex number. We'll represent it with the real part and imaginary part. And here we can create a complex number. So here we have x.r, x.I. So x is an imaginary, it's a complex number. So x is complex. I'll do it here. So x is a complex number. Okay? And you have x.r, x.I. We can do something like this. String of x, and well, we can define something like this. Like here this is how we build actually an object of a class. We build it or we construct it. It's like this is the constructor. It's also a paradigm of object-oriented paradigms, and this is a constructor in Python. If you're like doing Java or you have done other OOP languages, this is the constructor of Python, and this is how you would construct the this is how you put your class attributes in Python in here. It's like you create a function that is called init, and it takes self as parameter. It's the object, and it takes real part here. So self, we omit it when we call, and this is the real part, and this is the imaginary part. You can also like do something like real part, imaginary part, or image part equal and real part equal, and we'll have them like flipped around. Okay, so we can access them this way with positioning or with keywords. And we just say self.r. It's something really similar to Java. Java, you have this.r, attributes, and then you say self.r, it's real part, and self.i is imaginary part. So here, r and I are the attributes of xr, but not real part. Real part is not an attribute of x. So we have attribute error. So it's more just r. So just to make sure that you do the difference between the constructor parameters and the let's say the R attribute, like the parameters and the attributes of the class. Those are parameters of constructor, and those are let's say attributes of the class. Something that can be really interesting is to have this string. I've talked about it in previous class, and maybe it's not included in this, but I would do it. For example, we can create this function. Can create what is called the string representation of self, and here we can say return. We can say return x.r. Like we can return like this, since we have used this x.r. Let's say plus or minus your, just to avoid x.i, and we can do I here, for example. It will not be crazy if it's done like there is some formatting between negative, positive, but you can do something like this if they are both positive. For example, just for the sake of simplicity, you can just name them this way, and here we can say complex just complex like this. Complex like this, and we can do str of x, and it will say, okay, this is this kind of complex. It's complex 4.5 plus I3. Now this is how we would say what is our complex, or you can just take it off this one. And you have something like this. So this is your complex number. It's like 4.5 plus I30 imaginary and real. So this is the image part is 3, and this is the real part is 4. So this is another functionality of class that can be also very useful, like the string representation. You can actually have a representation of your class. You can also have other kind of representations, like and they are called methods, and we'll talk about them. Here we can see the instance of objects. So, for example, we have a counter, and while this counter is less than 10, we double it, and we print the last counter, and we delete this counter. So here we have 16, but here if we do exclude counter, we don't have this. Yeah, it will talk about this previous. Not here. We can add an attribute that is to the class, since here we still talk about our complex objects. Here it's our normal complex objects, and we can add to it. Actually more attributes, and we can add them and delete them. Here we add them, and we have printed it, and here we have deleted it after having it. And here you can see after deletion, because we have deleted it. Just here we can't access it here. They say, okay, we don't have this attribute. This is how to add and subtract attributes outside of the class, for example, but from the objects. So objects of classes, they can be mutable. Like the attributes of the class in Python can be mutable. You can add attributes without adding them in the class itself. Forward, we have class and instance variable. Let's say here, this is, for example, how you can have a method. This is how you call the method. First, we have seen how we can call the attributes. Here we can say it says objects and attributes. And here we have, it's more how you do like class instance variables and methods. So let's say you have a dog, a class dog that's also like the main. I won't go really deep into how OOP work, but the main usage of OOP is to have some kind of classifications. That's why they are called classes. It's like a class, it's like a factory, it's like something that you can make a lot of it. Like, for example, dog, you have a lot of kind of dogs, you have door, a lot of kind of doors. Those are mainly why they are called objects and classes. You can create a lot of objects of the same class. It's like a blueprint, let's say. Just for the ones that I'm not very comfortable with OOP and how it does work. So let's say we have a dog. It has a kind. It's canine, and this dog has we can initiate. We can create more dogs with their names. So this is the constructor. Here, so we create two dogs. Okay, create two dogs. We have one Fido and one Buddy. So d.kind, it's canine. Like both of them, they are canine. Like we said, that this dog would be always canine. And this is the kind, and we have the name. So we have different names for the same kind of dog. Here we have d.kind will be canine, e.kind will be canine, d.name will be Fido, and e.name will be Buddy. So they have different names, same kind. Here we can this is something we have. Yeah, exactly. This is something we have to look at. It's how we want to really differentiate the access to those variables, because those are kind of general variables or attributes that can be shared across the objects of the class, and we don't want to change the whole class attributes when we change an object's attribute. So here, for example, let's say we still have the name and we still have add trick, but we want to, for example, add tricks just for Fido, but not for one for Fido and one for E. If we do this, we add for Fido and for body. D.tricks and E.tricks, they would have both 2 tricks, but we don't want this. We want D have just the roll over trick and E have just the play dead trick, because that's the meaning, that's the semantic of how we want it to be. So instead of having these general tricks in here, we will have it also inside the constructor, and this is why we have this constructor in Python, and this is the utility of this constructor, and this is also the utility of having this difference between having this constructor and having this place for some shared variables. So in Python, it really supports having shared variables and private variables, like public variables and shared variables this way, in this init function and this outside scope in here. So that's why this course is it's better coupled with scoping. So here, as you can see, after running this, we can have each one has his own tricks, because tricks has to do just with the object that is the object in that we use, like right now. Here we have some remarks about classes. For example, here we can have this kind of purpose storage, and here, for example, we can we can create a warehouse and print its purpose and region, and here we can just have another warehouse and change the region. Just be careful that this one would be here. We will update this class actually from this one. But you can the usage of class can be something like this. Like, yeah, the good thing about classes is you have just this code that is quite just English. You don't have some quite complicated coding, let's say, syntax, but you more deal with the code as it was English. This is warehouse, this is region, this is purpose, and that's mainly it. Next would be some functions that are defined outside the class. So here we have function that is defined outside the class, and we just say this function is the other function. They are the same functions actually. This one is this function, and g of self it gives this, and h equal to g. So here if we see, you can see the c equals c. Okay, and we can say c.f. So here f needs x and y. So here we see that definitely f is equal to this f1, and here it will give us, if we give it, for example, 10 and 20, it will take 10, 20, and it will be here 10 and here 30, and it will give us the minimum, so it should be 10. So it is 10. And here you can see that g is this one. It's hello world, so we call it normally. And we can have also h, it will be like g. So we can make methods be equal to each other and call them. So here you can see that actually C has three methods. So you can actually define a lot if you don't want to overwhelm your class and you have some kind of file where you have a lot of functions and you just want class to use those functions. You can just use them this way without too much writing all your methods inside the class. Can come pretty handy. So this is really useful in Python to have methods that are and functions that's equal to each other. Next forward, we can have a bag. So with an init function, an add method like init method as well, add method and add twice, and you can test it. So we have b equal bag of let's say it takes a list. So we better say, okay, bag of 111. Okay, oh yeah, it doesn't take anything actually. That's the thing. So here it doesn't take any let's say any input, but any arguments. But yet we have also not reviews. So we can do something just normal like bag b dot add 1. And we can do also b dot add twice, say 2, and here we can access b dot data, and this will have add 1 just once and add 2 twice, and it's in here. And another OOP concept in Python or in general, it's inheritance. So this is how you would inherit a class in Python. You would do the new class, like the class you want to create, that wants to inherit from another class, and between parentheses you would have the class you want to inherit from. It's like the base class. You would have the derived class that inherits from the base class, and it would be something like this. It's something really impressive about Python. It's multiple inheritance. It's also like something in C++, but not much in Java. Java is emulated through interfaces, and it's quite really useful to be able to inherit from multiple classes. So Python makes inheritance from multiple classes possible. So you would do it this way. You can have also like private variables. You would do it like this. Let's say you have this. You want well, let's say that private variables are not something that have got a lot of attention in Python development, and they don't have like a keyword of, let's say, private or something. But you can do a little workaround about it and have like this update. There is this let's say this double underscore. If you do a double underscore this way, it's called like a name mangling. So just, I hope you keep up with me here. Just some Pythonic stuff. You just call name mangling, and you can have this updates method, this update, let's say, attribute that is private just to mapping, and it won't be inherited to the mapping subclass. And let's say do this, and let's say here we have mapping 1. It's mapping of an iterable. Let's say give it a list 111, for example, and here you have m2 equal to mapping subclass, and it takes some keys and some values. Keys, let's say, I believe they are both iterables, and they are like 2, 2, 2, 2, 2, and here you have 3, 3, 3. Okay, fix the position. Okay, it takes just yeah, it's that's the thing. It inherits mapping subclasses. A subclass inherits from mapping, so it inherits from the initial constructor. So this is the constructor, and it inherits from it. And this is the update method. So we have an update method that is different in mapping subclass than it in mapping. but the constructor is quite the same. So here we created a mapping based on mapping, the first mapping subclass based on the second mapping, and here we would say, okay, we'll do an update, m.update, let's say iterable. Here we update with 3, 3, 3, 3, and here if we ms if dot update, it would be something like what we have done first would be like 4, 4, 4, because here with this inheritance you can see that we changed this this method. Here it was just one iterable, and here it's more keys and values. And here we can say, okay, 5, 5, 5. And here something that is quite interesting is, okay, let's say, okay, here m.update. Here we see that update is an object of mapping. If you see, we have mapping.update, okay, and it's like the method, and ms.update. Here it's subclass of method. And here if we do m.update, the mapping has no attribute update. Normally it should have and let's say, so it's, the thing is it's not it will take this, it's not it will take this let's say you won't have it as this, but you would have something, it will be represented by mapping updates, and this is what you would see. So you see, okay, here like this update method is like a private class. It's like a private method that is different from this private method, from this method. That's why here we are changing it. That's why we are updating it. So if you kind of like quite get it, is that here this update method is quite different from this one, and here we are, let's say, accessing this method from this subclass, but not really this one. And this is kind of what's happening, and what I want to show is this one. It's like this representation of this mapping update. And you can see it sometimes even in those kind of methods. Update ms update. So this is basically let's say with this name mangling. So you would get like a lot about it to understand it. It's you would say like Python mangling private attributes, and you would see like how Python actually let's say deals with those private attributes. Go up here. I would leave this link in my code so you can have a look into it. just to let you know, yeah, yeah, you can deal with private variables even in Python. So here, yeah, we can't really access this, but we can access this one. If we do something like this, I guess, yeah, that's what I was talking about. So if you want to access this kind of copy here, if you want to access this kind of copy in here, you can access it with this, and this is like a private copy of what you have. So this is a private variable of your mapping. You can't quite have it in here, like for example this one. It's massive clash. So anyway, so anyway, you have these private attributes that is, for example, in this one, yeah, in this one, it's definitely related to this one, and the other one would be to the other one, to this one. But it's quite how Python deals with it. If you want to have some private variables in your code. You can also have a use of empty classes. In here, for example, you have some class employee, and you just use it like a placeholder, and you can add the attributes as you want, like you were saying earlier. You can have like this John class here and access its data. A very important, actually, concept in Python or in programming languages are iterators. And we will get to understand them. So here, if you see, if you want to go into this one, we can, for elements in this list, we can print elements. So we have or elements in this tuple, we have the elements. Or key in this dictionary, we have the keys, and character in this string, we have the characters, and for line in my file, we have the lines. So this is my file.x. So all of those actually we call them iterables. So we have an iterator, and those are iterables, and that's what I was doing here. Like in this mapping, if you see, I was saying, okay, update iterable, and that was given to them a list or a tuple. So we call them in programming, they are called iterators because you can iterate over them. And we'll say where does it come from. So if we have S, it's ABC, we can create an iterator over this iterable here. This string can be represented as an iterable, and we can have an iterator object. It's a string iterator. Here we can access each element of this iterator by next, like next of IT, next of IT, next of IT. They will give us first value, second value, third value. If we do it another time, it will have an error, stop iteration. We don't have any other value after the C value, and it consumes it. It's like the files here. This one, it's definitely an iterator, since after that you can't do it. You can't go over the 11th line. Here we have some iterator for looping over a sequence. Let's say you can change this next. So as we have seen, we have this init functionality method of class. We have the iter of class, so it creates an iterator, and you can have also, you can redefine next. Like if you want to reverse something, you can just create an X that actually goes back, like it will be negative and returns. So here, if we want to reverse spam, we can just reverse it. We create an iterator. We can also like just do it inside here, and we can do an iterator over it, and we can actually do an iterator over the class. And if we do an iterator over the class, it will use this function. So iterator of class will just return self, which will be spam, but the difference will be in the next method. So if we go in this iterator, it will be inverse, so maps. So we can have a use of the iter and next and combine iterators with classes, and they have a lot to do with classes actually, because iterators themselves are classes. And this is an iterator. This class actually defines an iterator. So we define an iterator that is called reverse. Next forward are generators. So we have seen iterators. Now we can see also generators. So here we can generate with this keyword. We can generate data with this keyword. It's called yield. If you use this yield here, each data of this index here, we just use some sugar syntax into reverse. Here you can reverse with this kind of looping, with this kind of entries in the range function. It's like -1, minus step 1 from the other side. And here you can yield each data. You can yield data of index. For example, we just change actually the order. You give it data and data of let's say the last one, they would say okay, they will yield that data of that index. So index would start, let's say here at whatever minus 3, and it will well, not -3, but it will 4. The index will be 3. Sorry, it will be 3, and the data we will return actually the data of 3, and would be f, for example. And here we can print this f log. And here each time it's like we generate we create this generator. It's a function, and we give just one value, and each time we go into the generator, he will give us one value. So this yield actually, it's yielding just one value. This is the most important instruction in having a generator. So we have also generator expressions. We can sum like we have generators. We can sum them. Here we can chain them like with some join or something. Here we can sum them. Here we can, for example, we have this one. We have x and y, and here we want, for example, to do a dot products, and we will zip them together. We'll have a look into zip. Zip just will take will just join each 2 points together from like vertically. It will join 10 and 7, 20 at 5, 30 and 3, which is quite useful. And for x, y in this zip, and we will just multiply them, like multiply x and y, and in the end we will just sum them. Here and here we can just sum them. Here we will just open this file. We will read the lines, and we will see which words are unique here. Those are all like let's say operations on generators. So those are mostly generators. And here we have, those are the unique words in this file. Here we have valedictorian. We will, let's say we will take the marks of a student GPA and the student name for the students in graduates. Let's say we have this data in some database and we can get the marks out of them, and we can have the marks on both of them, and we we can define actually marks on. There's some other things we can do, like marks is lambda key lambda x. With this lambda expressions we have done this things before. We'll just key we'll do it on the let's say x0, if x0 is the student GPA, for example. Last would be data of golf, and here we can just return, if we want to reverse it, we can just return the list. Here we can apply this list function on the generator without forgetting that this is our generator. And that's it. I hope you really enjoyed this one, and see you for the next one. See you.